Hello students, welcome you all in the chemistry class. Today we discuss the third part of the chapter solution, which is colligative properties. Colligative properties are the properties of a solution which only depend on the number of particles irrespective of their nature. Colligative properties only depend on the mass of the solute or the number of particles, but not on the nature of particles. If we consider the vapor pressure term, as I told before, vapor pressure means the pressure exerted by the vapor molecules on the surface of a liquid at a given temperature. But for solution, the vapor pressure is always less than that of a pure solvent. The vapor pressure of a solution is always less than that of pure solvent. Why? Because in a solution, the solute particles present at the surface make a hindrance in the vaporization of the solvent molecules. For that, it is the solution which has always less vapor pressure than that of a pure solvent. If you take seawater and normal water, then it is the seawater which has always less vapor pressure than that of a pure solvent, that is pure water, because seawater is a solution and pure water is only solvent. So it is the solution which has always less vapor pressure than that of a pure solvent, and the lowering in vapor pressure depends on the number of particles of the solute. If you take more number of solute particles, then the lowering in vapor pressure will be less. So lowering in vapor pressure is one of the colligative properties which only depend on the number of particles present in the solution irrespective of the nature of the particles. Colligative properties are of four types, like relative lowering in vapor pressure, elevation in boiling point, depression in freezing point, osmotic pressure. These are the four colligative properties we have to discuss in our solution chapter. So first we discuss about the relative lowering in vapor pressure. So as I told, the vapor pressure of a solution is always less than that of a pure solvent. So under this relative lowering in vapor pressure, there is Raoult's law for non-volatile solute. Raoult's law for non-volatile solute. Raoult's law for non-volatile solute. In the previous case, there was Raoult's law for volatile component and Henry's law. Henry's law is for gas in liquid. Raoult's law for volatile component is for liquid in liquid. Raoult's law for non-volatile solute, it is the case of solid in liquid. So here we consider the solution of the category solid in liquid. So Raoult's law for non-volatile solute states that the vapor pressure of a solution is directly proportional to the mole fraction of solvent. The vapor pressure of a solution is always less than the mole fraction of solvent. That is, mathematically PS is proportional to Xi1. What is PS? Vapor pressure of a solution. S for a solution. What is Xi1? Mole fraction of a solvent. That is, if mole fraction of the solvent is more, then we can say the solution is more dilute. For why? That solution has higher vapor pressure. So PS is directly proportional to Xi1. This is the statement of Raoult's law for non-volatile solute. That is, Raoult's law, two types. The previous one was volatile components, liquid in liquid. Now this is non-volatile solute, which is solid in liquid. Or we can write PS equal to P naught into Xi1. What is P naught? P naught is vapor pressure of a pure solvent, which is a constant. Or we can write PS equal to P naught 1 minus Xi2. Okay, no problem. Or P naught minus PS equal to P naught Xi2. Okay, or P naught minus P star is written as delta P. delta P is P naught into xi2. Delta P is P naught into xi2. What is xi2? Mole fraction of a solute. What is delta P? Delta P is P naught minus Ps. This delta P term is called lowering in vapor pressure. The lowering in vapor pressure means it is the difference of vapor pressure of a pure solvent and vapor pressure of solution. So delta P means P naught minus Ps. P naught is vapor pressure of a pure solvent, Ps is vapor pressure of solution. Not for pure solvent, S for solution. Or we can write delta P by P naught equal to xi2. Okay, this term is called relative lowering in vapor pressure. So relative lowering in vapor pressure means lowering in vapor pressure divided by vapor pressure of pure solvent. So the relative lowering in vapor pressure is equal to the mole fraction of solute. Delta P by P naught equal to xi2. So this is also another form of Raoult's law for non-volatile solute. What it states? It states that the relative lowering in vapor pressure of a solution containing non-volatile solute. The relative lowering in vapor pressure of a solution containing non-volatile solute, that is the term delta P by P naught, is equal to the mole fraction of a solute, that is xi2. This is also another form of Raoult's law for non-volatile solute. So from this we can write xi2 is N2 by N1 plus N2 or W2 by M2 by W1 by M1 plus W2 by M2. So this is delta P by P naught. Okay, so this is the mathematical expression for the colligative property relative lowering in vapor pressure, which is expressed as delta P by P naught. So the term very common, 2 for solute, 1 for solvent, W2 weight of solute, M2 molecular mass of solute, like that. Okay, and if you consider very dilute solution, for very dilute solution, N2 is very less as compared to N1. If you take very dilute solution, then the number of moles of solute is less, very less as compared to the number of moles of solvent. So N1 plus N2 is nearly equal to N1. A larger term and a very smaller term, the sum is nearly equal to the larger term. So delta P by P naught can be written as N2 by N1, N1 plus N2 N1, or N2 by N1, W2 M1 by W1 M2. So this expression can be used for very dilute solution. Which solution is very dilute? It is known from the number of moles of solute and number of moles of the solvent. If N2 is very less as compared to N1, then we conclude that the solution is very dilute solution, for which this expression can be used to calculate the relative lowering in vapor pressure, that is delta P by P naught. Okay, and these colligative properties are used to determine the molecular mass of a solute, that is M2, for proteins or any macromolecules like polymers. For proteins or macromolecules, the molecular mass is very large, which can be determined by using the colligative properties data. Okay, so from the previous expression we can write M2 is W2 M1 by W1 into delta P by P naught. Okay, what is M2? This is the molecular mass of a solute. So from this expression you can calculate the molecular mass of solute, that is M2, which is the main essence or usefulness of the term colligative properties. Okay, so this is all about your relative lowering in vapor pressure. Okay, so what we conclude in relative lowering in vapor pressure, it is the solution which has always lower vapor pressure than pure solvent, and if the solution is more concentrated, then the lowering in vapor pressure is also large. The vapor pressure of the solution decreases, so the lowering in vapor pressure is large for concentrated solution as compared to the dilute solution.